Okay, I guess I'm gonna start. Welcome to the QCP uh, laboratory intro to R workshop. My name is Daniel Ha. My research mostly involved with the microbiome stuff, but today I'm just gonna focus on the R coding specifically. Kelsey, who's online right now, he's gonna be our secondary instructor who's gonna answer most of the question online today. So before we begin, I assume you guys installed R and RStudio before you came in, right? And did you guys download all the stuff from the GitHub? Yeah, perfect.
I wasn't able to download anything. Like I mean, I installed the app, but I cannot download the part one.
Part one,
Mm.
what was the issue?
Like when I click, there is no, I don't find any option for downloading.
Yeah, so once you download the material from the GitHub, you can unzip it, put it on the folder, whichever path you want. And then you can open up your RStudio like this, and you can click File. And you can click on Open Project. You can go to the path where you downloaded the GitHub data, the course material, and go to part one and open up the part1.rproj file. And this will automatically open up the project we are going to go through for today. And all the relevant data should be on the files panel on the bottom right side here. So once you have done that, okay, so let me send you the GitHub link. Come on. Okay, thanks, Kelsey. Okay, so everyone's good right now? Okay, so R is the most commonly used and powerful.
Sorry to interrupt. I have a quick question. I think I want to be sure that I open the right file.
Did you download the file from the GitHub?
I did. I was able to do all of that, and I just went through what you displayed right now in terms of accessing the file. But it looks like the file that I found in my folder is labeled differently from the one you showed us.
Did you unzip the file?
I did all of that. Yeah. Can you please show me the file name again, because the one I have here is
So what you need to so did you open up the part one R project here with RStudio?
Yeah, so how do I open that? I don't actually see that file, part one R project.
You go to file,
Uh-huh.
open project.
Yeah, I did all of that. Yeah.
And go to the path where you download the GitHub material.
No, I guess what I'm saying is that file is not included in what I downloaded. You see what I'm saying? Like if that file is not included in what I downloaded.
Yeah. Can you maybe, I don't know.
The only R file in my part one folder is just labeled part one. That's it. You see what I mean? Like I have basically, I have 2 Excel files. Then I have, yeah, I guess it may be the same thing. It's just showing, it shows the R icon as you have it in yours, but you just label part 1. I don't see the R dot R.
Can you share your screen real quick?
All right, I have to, because I'm using 2 screens. Let me,
Yes.
so give me a second. Let me log into the current screen and then show you that. Sorry for the whole of everybody.
Recording in progress.
Okay.
I just enabled the screen share, so you should be able to share it.
Yeah. All right, about to do that now. So I don't have the option to share. I just got a query that I cannot start screen share while the other participant is sharing. Did you get me?
You can go to security. And oh, it says all participants
Yeah.
to share screen card.
You should be able to share a screen.
All right.
Okay, I should
Oh,
share.
perfect. Now I can do it. So this is where. Okay.
Yeah, you have it there. So
That file, that one.
that file, you should open that file.
Oh, I see. Okay, it was labeled differently from your own. So
Yeah.
you must have a different.
It's likely that your Windows setting is hiding that very end of the file.
Okay,
or the
so that's
doc.
what I have here. I have it open here. Then.
Yeah, so you can open the part 1R there. Yeah.
Okay.
Yeah, you're good to go.
Oh, awesome. Thank you. Appreciate it.
All right. So I assume everyone is now on the same page.
Sorry, I am now, so I downloaded yesterday R, but I'm now downloading the RStudio. I don't know.
You haven't installed RStudio? You haven't installed the RStudio?
No, only the R. I think I installed now the RStudio, but I have problems with it.
Yeah.
Please?
Yeah.
But then it doesn't do the job.
Yeah, we have it here. Just let it finish it, and you can search RStudio here. Just let it finish.
Yeah, okay.
All right, sorry about that. So R is one of the most commonly used powerful statistical programming language out there, especially in the science field nowadays. We use R more often, plus the Python as well. And it is very easy to learn and easy to once you learn how to do it, you can easily change the data type you want and easily use it to visualize your data, as well as some of the statistical analysis. So R basically reads your data. The most likely your data would be in a form of Excel or a text file, which have like some descriptive variable as well as some quantitative variables. So you can do some statistical analysis. And what R and any other programming language does is that it loads your data into a computer memory, right? And once it's loaded to the memory, you can change the variable. And when you're editing a file on the memory side, you're not changing anything on the file side, right? So anything on the hard drive is not changed unless you save it at the end. So this way of programming, is called non-destructive editing. This is just a fancy word for the one I just described. Yeah, so like I said, R can do almost anything you can think of doing with your data. So this that you just opened up, the part1.r is a R script file, which you can save your code. And as you can see, anything comes after the pound sign is a comment. So anything that you write after the comment is not gonna execute it in the R command console down here. So let me give you an example. Well, before I do that, let me just talk about the layout here. So RStudio is is a development environment for R. So R is a language code. So if you install R, you will likely have this terminal based console. But if you install RStudio, you can have something like this in the panel, where on the left-hand side, top left-hand side, you will have your R script, and on the bottom left-hand side, you will see the console where your code will actually get executed. And the right-hand side here, top right-hand side here, you're gonna have your environment where you will see all your variables and functions that are stored in your memory. And the panel down here is you will see all your files in your current working directory, and the plots is where if you visualize your figures, it will be plotted down here. And packages will show you all the list of packages that has been installed. And so it basically provides a graphical user interface, so you can easily do things in R. And help is obviously one of the important panel also. If you're running on like new functions or anything, you want to run help first. So you can, one way to use the help panel is you can just search it here. Let's say we're looking for the manual for print function. You can type print here. Or easier way on the R script side is you can put the question mark up front and then write down print. And a shortcut key for executing the command on the R script is a control return. For Mac users, it's going to be command return. So if you do that, you will see that this entire line gets copied into a console, and then the actual command is launched. So as you can see, print, the description about the print function is shown in the help panel again here. And yeah, so back to the commenting. So like I said, anything after that comes after the pound sign won't get executed. So for example, if I write print flow R and command enter, it will print hello R, right? But if you put the pound sign in front of it and do the like command enter, it's not gonna print anything, right? So for the sake of this course, you can use the commenting to leave your own notes and and stuff like that. Yeah, so I looked at the rosters and realized that most of you have a zero coding experience, right? So this course is designed for those of you who have like a zero experience in computer coding. I know some of you have like intermediate skills, but please be patient and I guess respect the fellow classmates. So for today's, this is a 3-day workshop. For today's material, it's gonna cover most of the stuff in the part 1. And part 1 will be also shared in the day 2 material, cover the day 2 material as well. On day 3, we're gonna work with the part 2 data in the GitHub material. So for today, we're basically gonna learn. We just did how to find help. And I just talked about the RStudio, and I'm also gonna talk about some of the cheat sheets, which is a good resource material that you can use as a reference for the future coding. And we're gonna talk about different types of variables. And then also the conditional statements, which is an if-else statement. And and we're also gonna talk about the loops, functions, how to install packages in R, loading the packages, also known as the libraries. And we're gonna learn about the different data structures, classes, how to import data, and how to examine data sets, right? Yeah, so a little bit of configuration. So you can, in RStudio, you can change the aesthetics of the software. So if you go to tools and global options and go to appearance, here you can change your font size if you want to. And you can also change the theme of your R script here. Whatever feels easier for your eyes, go ahead and change it. Guess I'm gonna change it to Eclipse style for the workshop. Do you guys think this is easier to see or no? Sorry. How about this? This is better.
Yeah, the dark background.
Okay. Okay. What about the font size? Okay. Better. And also on the code panel here, you wanna make sure you wanna check the software R source files. In that case, it's gonna create a new line at the end of the screen here. Okay, so if you go to global options, go to code, and make sure you have the check mark on the software R source files. So if you don't check it, let me just show you as an example. Yeah, you're just gonna have to scroll all the way down to read the file. Oh yeah, so I just talk about the different panels and terminals. Oh, good. So if you go to tools, global options, code, and then self-grab our source file. All right, so let me dive into, start talk about the variables, different types of variables in R. I mean, any kinds of coding languages, variable assignment is one of the like basic stuff, right? So you get to store any value into a specific variable name you assigned. So here I'm just gonna use the A for my variable name, first variable name. So I'm gonna store A equals 1. And if you do like control return here, you see that, sorry. Yeah, you see that so this environment actually shows what's stored in your memory. So in your memory right now stores number 1 in a variable A. This is what it means. R also accepts the arrow sign, so you can, instead of equal sign, you can use this one. So A arrow. Let's change it to 2. So if you do that, the value will get changed. And if you store other number to B variable, let's say we store 4, and after that you can do like simple simple addition to check, right? Also A plus B is 6, which is 2 plus 4, right? And you can also store a character variable, which is down here. So other than number, you can store a character. So if you do that, and if you print the A again, you'll see now the numeric number is gone and the word is replaced. Okay. And what happens if you do addition of this? And it creates an error, of course, right? Because you can't add a word with a number. I don't have anything my number. Yeah, so you gotta execute this line. So you can do that by pressing control and enter. Okay, now that's done. Yeah, so basically everything you run in R should be executed down panel here on the under the console here. Well, I forgot to mention that if you want to run multiple lines, you can drag your R script like this and do the same thing, like control enter. It's gonna basically run the entire code that you drag. There's also a vector type of variable, which basically means you can store a number of sort of like an array. You can store multiple variable into multiple numbers into one variable, either number or character. So if you do that, you see that now the variable A contains the number 2, 3, 4. And if you do addition, if you add the B into A, let's see what happens then. Yeah, so you basically it's gonna add every number into this variable. So 4 plus 2 is 6, 4 plus 3 is 7, 4 plus 4, 8, right? Mhm.
Why is there a C before?
Yeah, so C actually stands for concatenate. So it means it tells the R to store multiple value into one variable, basically.
So without the C.
No, without C command. It's gonna throw an error. So if you want to store multiple variable, you must have a C in front of it. There's also
Sorry to interrupt. Quick question. What key do you press to run? To like so I was trying to run some of the examples you displayed. So like A equal to 1, but I couldn't run it.
what's that?
How do you, excuse me, sorry about that. How do you run a command? So for instance, A equal to 1, the first example you have up on the screen, what key do I press to run and to execute it?
If you're using Windows, it should be so your cursor has to be on the line you want to execute. And then you're gonna press Control and Enter.
All right, let me try that. Control and I'm actually using Mac. Actually, Control.
If you're using Mac, it's gonna be Command Enter, Command Return.
You can also click on the Run button in the top right.
Oh
if
yeah.
you have different keys on your keyboard.
Oh yeah, where's the Run button? I was actually looking for that.
Here.
Oh, perfect. Thank you. Oh, nice. Thanks.
All right. There's also a another variable type called a data frame, where you can store. Oh, by the way, this is a little shortcut for R. So if you wanna write a series of number, like let's say you wanna print out 1 through 10, you can use the colon sign here. So if you do this, it's gonna generate every number in between 1 and 10. So if we use that and create the data frame, yeah, let's see what happens. So instead of values here, you see that now the data frame is stored under the data. And if you print this out, you will see that so it's like a matrix. It contains, so this represents the column name on the top, A, B, C, and column A contains 1 through 10, column B contains 21 through 30, and column C contains 31 through 40. So please note that the data frame, you should always have the same row number for each column. So if you like change it to something like this, which have a different length, right? It's gonna throw an error. You can also view your data by clicking your variable on the environment panel here. So you can double click it and you will create a separate tab and in a quite good visualization here, other than plain text, right?
So whenever you're generating a matrix, you use the data frame function instead of the cat name.
Yeah. And if you're dealing with data, you're mostly likely gonna deal with the data frame a lot. So this it's good that you get to familiarize with data frame variable types. All right, so going forward, let's move on to if else statement. So we just learned how to assign a variable. Now it's time to learn how to use the if else statement. So there's like a very common stuff in the programming language. So any programming language you learn, whether Python, R, C, Java, they're gonna have a similar syntax. If else statement is gonna be a similar. There might be some differences in grammar, but like the idea is basically the similar, right? So let's say, so we assign the b equals 5, set the b equals 5, and check is b is greater than 1. So if this is true, let's print true, or b is bigger than 1. Else, you can print is not bigger than 1. And obviously, if we do this, since b is equal to 5, is obviously bigger than 1, so it's going to print this one. But if we change to 1, as you can see, it's going to fall onto an else statement here. So if else statement is quite useful when you are dealing with when you're actually filtering the data. There is better way of filtering the data in R, which I'm going to talk about later in this class. But basic principle that how filtering works is basically through the if else statement.
What's the use of the value brackets?
Oh, so it's working as a wrapper. So if you write down the multiple stuff down here, so if you use the curly brackets, so it's gonna combine everything. It's gonna consider as a one block, okay? So everything that falls onto this condition and everything under this bracket will be launched. Yeah, similarly, you can also compare a string, I mean the character as well. Let's put down it's cool. And so for conditional for the stuff you put in here, so one equal sign is used to assign value to a variable. So if you want to compare the variable, you got to use the double equal sign here. So if you do R is cool. Yes. And obviously, since we have R is cool, it's gonna say yes. And if we put something else on the character variable here, it's gonna print no, since this is not equal.
Are these strings case sensitive?
Yeah, it is. Yeah, so string is case sensitive. So if you do this, so it's basically gonna fall under the else part here. You can also have a multiple conditions if you want. So you can have so you can use else if and curly bracket and put the whatever the condition here. It's good. Yeah, so as you can see, we have three conditions here. By adding the else if statement, we are also checking whether the string is R equals R is good. So as you can see, it is true, so it falls under this else if statement. So for to check the numeric conditions, you can use the following characters. So this is obviously a greater than, and less than. Let me write that down. Greater than, less than, and if you want to do like greater or equal to, you can put greater and equal sign after it. Similarly, and this is equal. All right. I guess that's enough for the if else statement. So I guess we can move on to the loops.
So I have a quick question about the if else statement. Can you please scroll up to the code you wrote? So I'm trying to understand how R operationalizes this. So if B double equal R is cool, then print yes. Is that creating a new variable?
No, so that's why we are using the double equal sign here. So if you use the double equal sign, it's just gonna compare the variable. So variable is assigned only if you use the single equal sign.
Okay. And so what does comparing the variables do? I'm trying to understand how that's a little bit confused as to what that executes.
So right now here we're storing R is good, right? So here, so it's gonna run through different conditions here. So on the first condition here, we're gonna check if B is equal to R is cool, right? But it's not, right? So it's gonna pass on to the next condition here, which is B equals R is good, which is true, right? And then so it falls under this block and it's gonna execute this print R is good. You get it?
Yeah. So on print here, just what we print, what are we achieving with that when we do the print?
So this is very simple example, but in the real type of data analysis, you might want to check. Let's say you're checking a statistical significance, right? Let's say you're checking whether your p-value is smaller than 0.05 or anything like that. So you chances are you might have like lots of variable with the different p-values. So in that case, you want to do stuff like if your number is smaller than 0.05, and you can print out whatever variable that is.
I see. So you would just like print it out, not necessarily creating variables. Got you.
Yeah.
All right. Thank you.
I mean, you can do like a lot of different stuff. Right now, I use a print as an example, since this is a very simple way to demonstrate it. But as we move along, you're gonna learn much more stuff. So you can add more code in here under this conditional blocks. All right, so now we can move on to the loops. There are different looping method available in R. But most likely you will use the for loop the most. There's also a while loop, which I'm going to talk about soon, but let me just comment this out. So let me just create a small vector here. 1, 2, 3, 4, 5. So if you print just the vector A here, it's gonna print the entire stuff that's on this A variable, right? But what if you want to print a single variable at a time? So that's where for loop comes in handy. So you can do something like I in A. So what it means is that go through whatever stuff in the A and print, you can say print I, and let's see what happens. So it's gonna basically iterate the entire vector here, entire element in the vector here, and it's gonna print one element at a time, right? So in one iteration, it's gonna obviously get 1 as a value, and second iteration is gonna get 2, and third 3, and the number goes on, right? And you can also play around with this, maybe add some if else statement into here. So maybe you can just generate some random number. Let's put some random number here. Let's assign C as 10. And maybe we can play with this. If I equals 1, and we can say add it to C. Else if I equals 3, in that case we can actually multiply. And let's see what happens. So as you can see, C is assigned with number 10. And if we run this for loop here, now numbers got changed to 33 because by iterating through this vector, as we hit the first element here, we just added the 1 here, right? Which now changed the C into 11. And then the second one will be skipped because we didn't meet our conditions here. And the third one, which is equal 3, and then which falls under this block here, and it's going to multiply the 3 here. So 11 times 3 is 33. Yeah, so you can expand your coding skill by putting stuff all together, basically. And the other loop is a while loop, which is not very commonly used in R programming. But I'm just gonna demo it anyway. So the stuff that goes into here, into while loop, is a conditional statement, something you put in like if else statement, right? So This can be quite useful if you're doing some iterative process, like you're adding, let's say C equals 1. And let's say C is, while C is smaller than 10, we're gonna add number to C actually. Let's assign random number. Let's just C, and let's print the C and on every iteration. So let's see what happens. All right, so you can see the while loop actually ran twice here. Also, as you run, so first we assign number 1 here, right? And then as we go through the while loop, it's gonna add number 6 to the C on first iteration. So that's why we see number 7 here. And then we printed the number. And that's on the second iteration. As you can see, the number now became 13, which is bigger than 10. Now it kind of exits the while loop.
Instead of doing 1, 2, C plus equals 6. Taking 5.
Even this?
No.
Yeah, I don't think it works here. Yeah, so syntax is a little different from Python. All right, I guess that's enough for the loops, and let's move on to functions. So as you code more into R, you will likely find that you're running similar code over and over again. So once you realize that, once you're running the code like routine based, you want to start wrapping up your code into functions. That way you can simplify your coding. So for example, here we wrote a bunch of for loop statements, which is basically takes about 10 lines, right? But if we want to like try with different variables, for example, I mean, we can't really copy different lines of code over and over again. This is waste of space and waste of lines, right? So if you want to iterate this for variable D, you want to change it for D and E, and already it became a 30 lines of code, right? So to avoid that, you want to wrap things up into a function. I'm just going to copy this to the bottom section here. So to create a function, it basically you got to name the function first, and then you assign, similar to the variable assignment, you do the little arrow here, and then you call it a function, right? And then you can stop. So data here is that whatever the input file you get inputted for the function, and then you can put down whatever the lines of code you want to run here. So I'm just going to copy this for loop into my test function here. And instead of A, we're going to use the data variable here. And And we're gonna return whatever is added to the C here, right? So if you control enter here, you see that now on the environment panel we have functions that is called test function. So I can add maybe let me create a simple vector here. C 1, 2, 3, 4, 5. Yeah, so basically, as I have shown before, so this one line of code actually, once you save the function into a memory, you can use this one line of code to run this entire for loop actually. So now it gets easier, so you can try different variables. So instead of 1, 4, 2, 6. Yeah, so let's change the variable a little. So here, now you can throw different variable into a function. Now it's gonna run the same line of code and do the similar functions, right? And once you become a kind of expert, you're gonna have multiple functions of your own. Once you have that, you can create your own packages. So packages is basically a collection of multiple functions, which we're gonna talk in our next section. But I think this is a good time to have a break.
Can you go over the function for once more?
Function?
Yes.
You want me to go in one
So
more time?
if you have data there,
Uh-huh.
so you can just use the function to re-isolate on different variables.
Pretty much. You can also put in pass on multiple variables here. So instead of assigning C to 10 here, we can put it as an input here, and maybe we can put different number other than 10. Maybe we can put 40 here, and redo this. Yeah. So since we structured the function as there is a two variables as input. So if you put in the one variable here, it's gonna throw an error now. Got it?
Hey, Dan.
Yeah.
We have a question. Can you go over again how you got 33? Maybe just the setting the variables, I think would help them.
Okay. Let me just read the chat real quick. Okay, so you don't understand how we get 33 from the whole code. Okay. So basically we're assigning C as a 10 here in the function, right? So initially C is a 10. And as then we passed on this vector here, and it's gonna iterate through under this for loop, right? And obviously the first element is 1, so it's gonna fall under this if statement. And since this is true, it's gonna add 1 to the 10 here. This is what it means here, C plus I. And then for the second iteration, it's gonna be a 2, which doesn't fall any of these conditions here, so it's just gonna pass. And the third iteration is gonna be 3, and we have a condition that matches here, right? I equals 3. And in this case, it's gonna multiply the whatever the value we had with the 3. So we had 11 from the previous iteration. So it's gonna multiply 3 here. So C actually end up being 33 at the end. Okay. Okay, oh, I guess it's a good time to take a break. I guess we're gonna resume at 10:10. All right. Yeah, I guess just quick announcement for those of you who's taking it for credit. There's gonna be a homework assignment as well as the quiz at the end of the workshop, day 3 of the workshop. So just keep that in mind. I'm also gonna send the quiz and the homework materials to everyone. So even if you're not taking it for credit, you can, maybe do some practice, additional practice. Okay, move on to the next section. Now it's gonna be the week after a week after day 3 of the workshop. Yeah. Which is, I guess, 27th of October. Yeah, so far what we have learned was some of the basic stuff in R. So now we're gonna dive into how to use the packages, which is basically a collection of predefined functions that other professional developers have made before. So these are one of the common packages that we're gonna use for this workshop. So in order to install the packages, the commands are like this. So it's gonna be install packages, tidyr, install packages dplyr, and the list goes on. So you can go ahead and install tidyr first. And it's gonna start downloading some stuff from the web, and this command basically gonna install it automatically. And once you have it installed, you should be able to see the packages in the packaging tabs here. So if you search tidyr, you see that I have 2 versions here, but like you should be able to see the installed packages here. You can install packages one at a time, or you can also install multiple packages like in a single line like this. So basically you can concatenate the library name, the package's name. So here we're gonna install, along with tidyr, we're gonna install dplyr, table, or color brewer, ggplot2, and lubridate. So I'm just gonna execute this one line here.
Hey Dan, do you know if they need our tools to run these packages? Is it necessary? Or is it just a warning?
So if you're compiling from the source code, it might require the R tools. But if it's just warning, it should be okay. Susanna, can you check whether you can load the packages?
It worked for me.
Okay.
How about you, Anne? Are you able to load the other packages and just get the warning? Otherwise, I'll keep looking for the,
I'll try that right now.
okay. Because it may just be warning you. There's a lot of update warnings you get sometimes in R.
Yeah, it looks like I can't even load the library.
Okay.
Yeah, in that case, you want to install our tools, I guess. So you can Google our tools. So the first thing that pops up, you can basically install it. So whatever the version you have, you gotta install the right version, the version that's compatible with your R. So you can also check your version of R if you type in session info into the console, and it's gonna throw out the bunch of strings here, but at the very top of the line, you will see the R version here. So mine is currently 4.1.0. So if I would install the R tools, I'm gonna install this one, which is basically covering the version 1.0 to 4.1.3, right? Okay, how many of you like having trouble loading the library?
I think there's maybe just one or two so far, but it seems to be a Windows specific problem.
Okay. You're using Windows?
No.
Okay. 1 second. Oh yeah, no, just demo that. Yeah, so once you compiled everything, you can basically load individual library with this function called library. So library tidyr, it will basically, sorry. Yeah, if you install everything right, it should load it, and then as you can see on the packages panel, once it's loaded, it will have a like a checkbox check on it, right? You can also load library in the packages panel here. So dplyr, you search dplyr, you can check box here. Yeah, so it basically does the same thing, same command on the R console. If you just press the checkbox here. Or if you're running a multiple packages, you can run it one at a time, or you can also using this code to run it in a single command line. So you can store everything, every package's name you want to load into a variable, just pick packages to load and apply on this function here. Yeah, so basically this, what this function does is it's gonna apply. So it's kind of working as a looping that we just showed in the previous section. So it's gonna go through each element in tidyr, and it's gonna load that element using the library function here. What errors? Here is the version is kind of stuff.
I guess when now. Yeah.
Pretty good. They have just some kind of videos.
No, you can leave everything as it is. Yeah, so basically I talk about how to find help, how to use the help function in R. Some packages have a good documentation and good manuals to search the help. Some does not. So in that case, you want to search through the web. Google is a nice place to work with when you're having trouble encoding, and other web pages like Stack Overflow. And yeah, also I provided some cheat sheets for data import, and here, let me just copy this real quick. Yeah, it basically has a list of commands that are commonly used for data importation, as well as some of the functions that is widely commonly used for tables packages that we just loaded and tidyr. And for data transformation, yeah, so this is basically a cheat sheet for deployer package. So you can use this for future reference as well. And this the cheat sheet about ggplot2, which we're gonna work with tomorrow's workshop mostly, is here. So you can use this as a future reference as well, if the help function is not helpful. All right. Yeah, like it says, the Google is a good place to troubleshoot whatever the trouble you have over the in our coding. Stack Overflow is also a good website. R bloggers and as well as BioStars is a good resource. If you're getting in trouble, it's most likely other people might have had a similar trouble before, so they might have a solution there. Okay, so now we're gonna learn how to import data. If you go to files, I provided the COVID vaccination data for different counties in US. So there are two types of data. But first, you want to make sure your working directory is where you have the part 1. You can check your working directory with getwd function here. And if this is not your part 1 directory, you want to change that. The way you change it is set wd. and you basically write down your path. So I'm storing my GitHub material under this particular path. So I'm just gonna write this down. Yeah, because I guess it's throwing error because I'm currently using this as my working directory. Not changing working.
I think you have an hyphen instead of an underscore somewhere. Okay.
Oh, yeah, here. Yeah, so the other way you can change your work directory is using this GUI panel here. So under files. So this basically shows your current working directory, but like if you want to change your working directory, you can basically navigate through this panel here. So if you want to change it to part 2 as your working directory, you can select part 2. You can go to part 2 and click on more here. And then here it has like a menu that says set as working directory. Yeah, so this will basically launch this command and set part 2 as a working directory. I'm just gonna set it back to part 1 as my working directory. Yeah, so although you can see all the contents of the files in this directory, you can also look through the files using dir command here, which you're gonna print out all the file names under this directory in the R console. Yeah, so one way to read the table is using the read table function here. So if we find the help function and see the manual here, we basically tell you what types of variable you can put into this function. So most simplest way is select the file names, which you can see under the working directory here. So we're gonna open the county data.csv file.
I have these documents here,
You
like my directory has different files that I can.
don't have the file.
I have it here, so I don't know. Like the copies. Here are all the documents.
Okay.
And
Where is your stuff you downloaded from the GitHub?
when I have it here.
On here? Okay, so you can put this as your working directory. Let's change this to. Let's just slash it. Oh yeah, you change to here. Change every backwards to here.
Yeah. And then-
Maybe this works. Yeah, you gotta change
Yeah.
everything to slash. Yeah. Oh, yeah.
Yes.
Oh, you can.
sorry, it says that time has changed working here.
Yeah. You can load the packages again. And then. Oh, yeah, so this is my path, so you want to change it to the. So where's your dollar? Okay, so it's fine. Yeah, so we can change this backslash to the spots. This. Everything. Oh, this is the single model. So you got on system, that's out of model. We're in the right path now. We just need to reload the libraries. Use no other way. Yeah. Reload, so it's follow. Yeah. See, like, when James came, yeah. Yeah, but the working directory has to change. And this panel is just for you to navigate. So it doesn't specify. But one way to check it is to check. Directory. And you can see part two is actually working directory. So when today we will set this mark one. Yeah, because this task is a random string, right? Because this doesn't exist in your computer, right? Yeah, so your actual task would be here, download, right?
Might be a dumb question. I think I need to- I mean, I can also just go to the screen. Like, I can only do it if I'm doing it.
Did you answer that?
I did in here and then I tried to.
Oh, where's the path to that?
To,
To that one with file. Directory.
yeah, it was like. Certain things. Yeah, I tried to put them all back.
No, that's.
Oh, it's.
All right, now it seems everyone's on the same page. Okay, so you can read the table in the following manner, So read table and the file name. Obviously, my current working directory is under part 1, so it does have a file called countydata.csv. So I'm just gonna name the file here. And whether it has a header or not, you can check it if you actually open up the file. Oops, sorry. Yeah, as you can see, our if you open up the CSV file, it's gonna open with the Excel. As you can see, it does have a header, which is basically a column name, right? So we're gonna set the header as a true. And since this is a CSV file, which stands for comma separated file, we're gonna set the separator as a comma. And if we do that, it's gonna load the data into in a form of a data frame. So if you click this, you basically see the same data structure in the Excel file. Was that?
Can you do it?
Do it again?
Well, just show. Did you write all this county top?
No, I didn't write it. So I'm just loading the file. So it should be under your part 1 directory. Oh, you can find the line.
Well, I read it.
Yeah, I see it. Yeah, so as you can see, since we set the header as a true, it's gonna say the rank, county, population, and pertain K as a column name. If we don't use the header, if you put the header as a false, let's see what happens. Yeah, as you can see, now the column name actually became a row in our data. So you gotta make sure that whether your data have a header or not, whenever you're importing a data. So I'm just gonna put it back to true. So yeah, for the true and false, instead of writing down the whole word, you can use either capital T or F as well. And you can also check the data, the variable types with the class function. So on the top, it will tell you which type of your data, I mean your variable is, which is a data frame. Since we use the read table, so basically read table gonna read your data, load it onto your memory in a form of data frame, right? And you can also access your data frame by column name. You can put little $ here, and it's gonna auto-complete all the column name here. So you get to select. So you want to print all the county. There you go. You're gonna see the entire list in your column, the county column. And so $F and then tab will show up this auto-complete function in RStudio. And for population, it's gonna show up all the values in here. Also, you can use indexes to access the data in the data frame. So you can use this square bracket here. If you wanna look at the very first element in the first column. So you can write down here. So this one on the left is a row number, and this one here on the right is a column number, right? So first row, first column value is a 1, which is our rank value here. So that's why we're getting 1. We get the second column number. It will be Los Angeles, right? Which is up here. Yeah. Yeah, so basically you can access the data within the data frame using either index or the column name. You can also do something, I think we can also do something like this. Yeah, so instead of starting with the index, you can start with the column name, which will give you a vector of all the county and the first element of county, which is Los Angeles, right? And the second would be San Diego, and the list goes on. Yeah, and there are these other functions available to read table instead of read.table. You can also use read.csv. So read.csv by default has a separator as a comma as a default, so you don't have to set the separator here. So yeah, so even though we didn't set the separator as a comma, by default, the read.csv has a comma as a separator. It should have the same result. Yeah. Well, like if you're working with actual Excel file, which is a tab delimited, in that case, you want to load the data with this particular sign. So this one is for tab, right? So for tab separated files use instead of yeah, so we just showed how the data structure of the county pub actually looks like. So you can either click on the environment here, or you can either to use the view function to pop up these separate tabs here. Yeah, so something about variable names. So even though I use like something very simple, like single letter, like ABC, this is a very bad way of assigning variable names. So when you're writing a code, make sure you write your variable names that someone else can also understand. So here we store the county population data as county pop. So this is obviously easy to understand. There are ways you can name it. Some people doesn't like to use the capital letter in the variable name. So if you wanna separate it, county, you can either use dot or underbar or dash, but you don't want to start your variable with the numbers. It's gonna throw an error, I think. Yeah. All right, so now that we have loaded the county data, I want you guys to actually try and load the another data, which is this one, right? And I want you to select the right separator. I mean, the answer is right wrote down here, but I want you guys actually try it. Does it have a header? Or which separator we should use? Should we use a tab or comma?
If the separator is tab, how do you indicate that, or do you just do it?
So if it's if the file extension is CSV, it's always comma.
Okay.
And if it's not, if it's like typical Excel file which ends with I think Excel as X, right? If it's this, that means the file is tab separated.
Okay. But so do we just not write, and is that like default tab separated, or how do we indicate that in like the
In the command?
yeah, like
Oh yeah, usually, so since this is a CSV file, you can just basically put the comma here, right?
but if it was an Excel file?
Then the tab
Okay.
separator, right? I mean, if you open up the CSV files with other text editor, you see that everything is like comma separated right here.
Okay.
Right, so you guys all had it? Good. Okay. All right. Oh, so I forgot to mention. So in the global, on the environment panel, you can also see if you're dealing with data frame, you can also see this number, right? 58 observations of 4 variables. So what it means is it basically tells you the size of the data frame, right? So this means 58 rows and 4 different columns. So obviously this is very large data, nearly 26,000 observation, 26,000 rows with 21 columns. So you can you don't have to even click the data to see the size of the to see the dimension of your matrix file, which is kind of nice thing in RStudio. You can also load the data in the web. So if you have the right links to the file, you can also load them. You don't have to even download the data. So here I gave you the sample URL for the file location. So as you can see, obviously this is a CSV file, so comma separated, and it does have a header. So I'm setting the header as a true. And this is, I think this data contains the measles vaccination rate. Yeah. So go ahead and load the data. It's going to take a while. It has, so since it's getting the data from the web. Actually, while it's loading it, I think it's a good time to have a break. This is 11. So we're gonna resume at 11:10, I guess. Yeah, so as you can see, the measles vaccination rate data is quite large. It has nearly 66,000 rows and 16 columns. That's why it took a while, since it's also downloaded the data from the web. So yeah, one thing about the data frame is that you can check, like I said before, you can check the types of the variable using the class function. So if you check the COUNTIVEX data with class function, you see that this is obviously a data frame because we loaded it from the read.csv function. But if you note that if you put down the different columns, you see that different columns have a different class of data. So data frame is basically a collection of multiple types of data. So you can also see that you see the population. It says numeric. Obviously, this is true because this is a number, right? And you go for county. I mean, you can check each column in this way, or you can use the function called structure. So if you use the function structure, you can basically, it's gonna report the class, the type of variable of entire columns in your data frame. So it basically summarizes the different data types in your data frame. So here, date is a character, county is a character variable. Bits is an integer, population is numeric. And yeah. And you can also change your variable types using this method called as dot and the variable type. So if you let's say example, we write down one. So what's the class of this example, for example? Would it be number?
Yeah.
Huh?
Yeah.
Yeah, it should be a character because we wrap it with the quotation mark, right? So if we check it, even though it's a number one, it is a character variable. So if we do any mathematical operation here, like if we add a number here, it's gonna throw an error, right? So in order, sometimes the data is provided in the form of a character. So you want to make sure whether the numeric value is in actually numeric class, numeric type, right? So you want to change that. In order to change that, you want to use as numeric example, and we're going to store that back to example variable. So if we do that, let's check the class again. Yeah, now it's numeric, right? And we can do some addition here. It's gonna do just fine. Yeah. So you can also check different variables in CountIPop. I think one of the columns in CountIPop is in string, even though it should be a numeric or not. Yeah, you see that population is actually a character. So if you print out, you see that every value is wrapped with the double quotation mark here. That's the indicator for the character variable. Yeah, so you want to change that to a number, right? So similar to example up here, we can do something like this. CountIPop column population, but you want to wrap it with the as numeric. Yeah, it says NA is introduced by coercion because there are some values. I guess some of the values had a empty. Oh. For some reason, everything turned into NA. Let me reload the data up here. Oh, I think I see. Yeah, the problem has to do with the comma here. Yeah, because our number has a comma in between. What's that? Yeah, so integer is anything from above 0 to basically an integer, right? And then numeric can contain some decimal numbers as well.
Question. My laptop is on the version, so will be going to comma and dot make a problem here. Like in your the dot will be instead of this comma, the comma will be a dot.
Was that?
Like in any Excel, I know that in Excel you can cause trouble that numbers with comma is a very common but in Europe we use the comma just to have decimals, and we use it. I mean, we would use a dot instead of the one here. Oh, really? Yeah. So I know it happens to me with Excel file that it can have trouble with that. I don't know if you can experience this before. Just to know it could be any trouble in R.
Yeah, in this case, it's already creating a problem because we get changing the variable type, everything turns into an A because it doesn't consider the absolute number, right?
Okay.
So I think in order to change this, we need to use another function. Let me actually let me talk about this tomorrow. Actually, I'm gonna you're gonna need to install additional package to deal with the string here. So what we are going to do is we're gonna replace every comma into we're gonna delete all the commas in between numbers, and then we're gonna turn it into a number. All right. Yeah, so I guess you can also play around with the different data frame we loaded here. You can check different column names. And you can also play with the structure function here to see the contents of the MMR fixing rate and the different class. And obviously, the county is a character variable. So if you're trying to change that to a numeric, it's gonna throw an error. Not error, but actually it's gonna change everything into NAs. So you gotta watch that. You gotta make sure that your your column you're converting is actually a number. Right? Reloaded. Another useful function for data frame is the column names and row names function. So if you use the column names, it's gonna give you a list of the vector of all the column names. And row names, which is basically a number of indexes, right? In this case. You can also use this call name function to change the certain column names if you want to. So it will be something like so if you want to change date into capital letter date, then let's see what happens. Yeah, you see that date has been changed from the small letter to capital letter, the D. There are also some useful functions for data frame, predefined useful functions. So mean, median, standard deviation, and I think this one is for quantile calculation, and mean, max, quantile. IQR, also IQR4. Oh, interquantile range. And you can also find the first function to locate the first element in the data frame last, and you can specify specific rows and columns with n. And this particular function is used for counting the data. So for example, if you want to calculate the mean, yeah. Yeah, thanks, Kelsey. Yeah, if let's say we want to calculate the mean of the population here. So we're gonna use the count vex data and population. It's gonna the mean population of the entire county. And summarize here is one of the default, one of the functions provided from the dplyr package that we just loaded. You can also use this. You can pass the data frame as first variable, and then you can also say whatever the function you want to, grouping function that you want to use at the second parameter here. Okay. Maybe I've done something wrong. Oh. Nope.
The autofills, they'll summarize with an S.
What's that?
The autofills, they'll summarize with an S, not a Z. Does that?
Oh, it doesn't matter actually.
I think the top one is also.
Oh, the capital? No, I don't think that's an issue. All my computing. Oh, actually. Yeah. Yeah, I think the entire data frame should be a numeric. So if this mixed with some string descriptive variable, it's gonna create an error, I think. Oh yeah. So I guess to summarize, you pass on the data frame, and then you designate whichever grouping function you wanna do. Here I calculate the average of the population. So we know that we have a population column here, so we toss that on to the mean function. And as a result, it basically tells you the mean of a population. So actually, let me write that. Mean population. So it creates a simple table that tells you the mean, or you can do other things like the mean plus the minimum smallest number in calculation is about 1,000, right? Yeah, you can also select. So mean is a predefined function in R, so you can use that. You can use it. You can use that for a specific column like this, but you can also make a table, table of summary using the summarize function. So here you can use mean, population. So you see that it's the same thing that it's doing. It's just summarize is just creating a separate table, like a report. Know what I mean? No? Yeah, so we can now dive into more stuff about the dplyr. It's basically a data manipulation tool that you can actually change the structure of your data frame. If you want, you can filter the data. So instead of using the if-else statement that we used previously, there's a predefined function that you can easily use to filter out the data from the data frame. So here we see that there are 4 different columns in our county pop data frame, namely rank, county, population, and per 10K. Obviously, rank is not, we're not interested in looking at the rank, so we want to throw that out. So we can do that by using the select function in dplyr. So way that this works is that you can pass on your data frame, which is county pop, and you can designate the number of column you want to save, right? And if you just run that, it's gonna print out basically the 2 columns that we selected, and you can also store that value, the table, the data frame into a separate variable here. So we're gonna name it as a county pop filter. And as you can see, since we have selected 2 columns here, we see that there are 2 variables with the same row numbers. So if you click that, you can also check that. Now that the rank and the population information is gone, we're only having these two columns specifically. Yeah, so also if you wanna like, if you look at the vaccine data, you see that they have the measles vaccine rate for entire states in America. So since if we are interested in the vaccine rate for California, we can also filter that out using the filter function. The way that it's worked is that you can always, the first parameter is always the data frame. And then the second is a conditional a statement that you want to compare. So here, the state is a column name, right? State, which is up here. So we want to filter out everything that is from California. So state double equal sign, this is a comparison, equals California, filter them out, store them into a vaccine CA variable. So let's see what happens. Yeah, as you can see, the data is now has been subsetted from 66,000 to 16,000. Since we didn't use the select function, we kind of kept all the columns from the vaccine rate data frame here. So you click it, you see that now that our data contains everything from California only. Yeah, so you can also combine the select and filter to filter out different columns and rows as you want. So you can play around with this if you want. I guess this is some of the materials that you guys can try, but we can try it together, I guess. So it says how many observations and variables are there in, basically how many rows and columns are there in full CountyVex data CA, which is this one, right? So we have 25,810 rows and then 21 columns. That's the variable. That's the condition. Yeah, and you can also use the column names to list out all the column names, call names function to list out all the column names in the data frame as well. Yeah, so for I guess that's it for today. For tomorrow, we're gonna learn like how to merge these two different data frames into a one data frame. Obviously, they have one thing in common, the county data. So we're gonna use that county data to merge the two different data tables together as a merging point. And yeah, and there are some good resource for you guys to read if you guys are interested in about this data. And yeah, I guess that's it for today. Yeah, the recording for this workshop will be posted. So it'll gonna Louis has the data, so he's gonna post, send you guys an email for the link for the recordings. All right. Thank you guys for coming.
So if you want to say what we just changed in the box one. There's a link on the
Oh, yeah, so. There's actually, part 2 kind of material, but like, if you want to save your data, you can write your table. So let's say you changed, the data,
or like right with another file.
yeah, so you can save it with this function, right? CSV. And then you gotta put on whatever data frame you want to save. So if you want to save county pop, and you want to designate the file path, the path you want to save. If you want to save it under the working directory, you just have to name the file. County pop 2 CSV. And then enter. Yeah, this should create the secondary CSV file as a result. Ready?
Yeah, I have a quick question, please.
Mhm.
Yeah, please, can you go over test function again? I didn't quite get that. How to use that statement.
You want me to go up to the functions part?
Test, yeah, wait. The one you annotated as 1.4 for today functions. So that's before.
This one, right?
Yeah. So, because so
Wait, let me stop recording real quick.